All right, correcting our papers for Doppler Effect. You can pause and check answers. I'm going to go through each answer, each solution in order. At the beginning of each one, I've made a large number, so you can just scan across the bottom if you want to scan up to one of the answers. All right, first problem. A foggy day, Kenny driving a speedboat towards a lighthouse. He has a speed of 15 meters per second, and the foghorn blows with a frequency of 180 hertz. All right, and what frequency does Kenny hear? So this establishes Kenny as the observer. All right, so Kenny's speed is 15. And it says that he's going towards the lighthouse, so we're going to make that a positive 15. Remember, if you're going towards, it's positive. If you're going away, it's a negative speed. So the lighthouse then is going to be the source. They give us the frequency of the source, and we're looking for the frequency that Kenny hears. What does he observe? The two numbers they didn't give us, the speed of sound, 340 if they don't tell you, meters per second. And speed of the lighthouse, obviously lighthouses don't move, so its speed is going to be 0. So plugging our numbers in, we're adding a positive 15 on the top and subtracting nothing on the bottom. Looking at this ratio, it's larger than 100%, so we should have a larger frequency than 180. Once we get our answer, you want to think about it. If we're going towards something, is it going to have a higher or lower sound? It should be higher. All right, next problem. Dad's driving the station wagon. They pull over to a rest stop. Junior's watching the trucks go by, and he knows they have a different sound going towards or away. The truck has a frequency of 85 hertz. So that right there is establishing the truck as the source. So we have frequency of a source. And then they go on to tell us that the speed of the truck is 27 meters per second. So that will be the speed of the source. They're asking, what does Junior hear? So he is the observer. And the key word here, they are at a rest stop. So if he stopped, his speed is going to be 0. And of course, the speed of sound is 340 if they don't tell us what it is. Now, the difference between part A and part B is if it's going towards or away. So for part A, when you're going towards, we have a positive speed. So let's plug in our numbers here. So on the bottom, we are subtracting a positive number. On the top, we're adding 0. Looking at this ratio, it's larger than 100%, so we're going to get a larger frequency than 85 hertz. Comes out to 92.3 hertz. For part B, the only thing difference here is that the truck is moving away this time. So we're going to change this positive speed to a negative speed. So when you're going towards something, you have a positive speed. When you're going away, you have a negative speed. Everything else in the formula stays the same. So notice in the bottom, this time we're subtracting a negative number, so we're actually going to be adding these two numbers in the denominator to get a larger number. This makes this ratio less than 100%, so we're going to have less than 85 hertz for our final answer. And this should make sense. If you're moving away, we should have a lower sound. If it's moving towards, we should have a higher sound. Problem number 7, about a mosquito. It says the mosquito's wings emit a frequency that makes the mosquito the source. And if you hear a frequency, you are the observer. You're hearing a frequency of 134. And the first question is the mosquito coming in or going away? So you're hearing a lower frequency. Sounds with a lower frequency happen when the object's moving away. Part B, they're asking us to find what is the speed of the mosquito. We have to assume that your speed of the observer is 0. So we're going to have to do some algebra here to rearrange our formula. We're looking for the speed of the source. So first I'm going to do is multiply both sides by this denominator, and then I'm going to divide both sides by the FO. And on the first day of school, I showed you some algebra tricks when you have something minus something. If I have A minus B equals C, and I want to know what B is, B and C can swap places. A minus C is B. So what I'm going to do is swap places with all of this and the VS, and that's how I solve it for VS. Plugging my numbers in, this time the hertz are going to cancel out, and I have meters per second minus meters per second. And we end up with a negative number, and that negative means it was moving away like we had thought. Problem number 8, Barney and Betty are both bumblebees. They're flying along. Barney's wings beat at a frequency of 90 hertz. That makes him the source. So I'll put him down as the source, and I'll put down Barney's speed for the source. And then that makes Betsy the observer. So she is going at a speed of 4 meters per second, and we're looking at what frequency does she hear. And speed of sound is still 340 if they don't tell us what it is. Let's look at their directions here. Barney look at his direction arrow, he's moving away from Betsy. If you're moving away from something, your speed is negative. Betsy's arrow is going towards Barney. If you're going towards something, you have a positive speed. So plugging these into our formula, on the top we're adding a 4, on the bottom we're subtracting -6. Subtracting a negative means you're actually adding those numbers in the denominator. This ratio is less than 100%, so we have a number less than 90 hertz is what gets heard. When we did our definition of the Doppler effect, we used the term relative velocity between the two objects. Barney is moving faster than Betsy is, so he is moving away from her. The relative velocity would be 2 meters per second that he's moving away from her. All right? And so if you're moving away, you should have a lower sound. That's what we would expect. All right, the last problem, Mr. Gonzalez's wife's giving birth. She's being raced to a hospital 30 meters per second, and Officer O'Malley jumps in his car, turns on his siren, has a frequency of 800 hertz. So this tells us the police car is the source. So I can put down the frequency of the source, and it says the speed of the source is 85. He's trying to catch up to him. All right, so that makes Mr. Gonzalez the observer. So he was going at 30 meters per second. We want to know what frequency does he hear. And again, we're going to use 340 meters per second for the speed of sound if they don't tell you. Let's look at our velocity arrows here. The police car is going towards Mr. Gonzalez, so the police car is going to have a positive speed because he's going towards him. Mr. Gonzalez's arrow, however, is going away from the police car, so Mr. Gonzalez is going to have the negative speed. So when I plug these in, on the top we're adding a negative, on the bottom we're subtracting a positive. So we're subtracting both of these terms, and we end up with a ratio that's larger than 100%. So we have a number that's larger than 80 hertz for our answer. All right, again, thinking about our relative velocity between the two objects, if this one is going faster than the front one, they're getting closer and closer together. When you're coming towards or getting closer together, your frequency is going to be higher.